a hydraulic press. A very, very classic problem to see on AP Physics 2 exams. All right, pay attention to this one. It's pretty easy. It's Pascal's principle in action. This is how they lift all the cars and the gas stations and that kind of stuff. Determine the force exerted by the output piston when this force here is 100 newtons. What will this force be? That's what we have to figure out. We know that this thing over here has a radius of 10 centimeters. And over here, the radius is 60 centimeters. Okay. Notice we have force pushing on an area. Pressure equals force divided by area. Interesting. Also, got ahead of myself. Also, something very important. A hydraulic press. You need to know what it is. This whole thing is a confined fluid. What does that tell you? Oh, Pascal's principle. And a Pascal's principle. Any pressure over here will be felt throughout the confined fluid. Will be felt here, will be felt here, here, wherever. You put a pressure anywhere in this fluid, it'll be felt throughout the fluid. So that's really important. So the pressure over here, the force per unit area over here, will be equal to the pressure over here. Now over here, we have a much greater area. But let's just think with this. So we're going to get, on this side, say force 1, area 1. Over here, we'll get the pressure will be equal to force 2 over area 2. But these pressures are equal. So we can set those two things equal to each other. We get force 1 over area 1 equals force 2 over area 2 because the pressure is the same throughout the fluid. They want us to solve for F2. F2, doing some simple algebra, would be F1 divided by area 1 multiplied by area 2. F2 is 100 newtons. Now let's plug in some area. Area of a disk is pi r squared. Right. So pi r in this case was 10 centimeters or 1/10 of a meter squared. Area 2 is pi r squared. R squared in this case is 0.6 meters squared. Oh, pi's cancel out. What happens sometimes? That cancels with that one. So we get 100 divided by 0.01, nope, sorry, 0.1. 0.1 squared is 10,000 multiplied by 0.6 squared, 36,000. No, 3,600. What am I saying? So the force 2 equals 3,600 newtons. That is the output force. The force by the output piston. Now this force is going to be spread over a bigger area, but it's got a force of 3,600 pounds. You only start with 100. Multiplied your force by a lot. But now let's think about this. There's got to be some cost. And here it comes. So this is part 1 of the problem. Part 2, if the input piston moves down a 1/2 meter, if this side drops a 1/2 meter, how far has the output piston moved? How much does this go up? Well, we can think about this in terms of conservation of energy, right? create or change energy, we can think of it in terms of force by a distance over here, force by a distance over there, 100 newtons by a distance of a half a meter. So the work done over here is 50 Newton meters. Well, the work done over here is going to be 50 Newton meters. But this force is 3,600 newtons times some distance. So 50 divided by 3,600 or let's call that 0.14 meters, 14 centimeters. This thing goes 50. This thing goes this, tiny bit. No, I'm even wrong. Look at that. Darn it. Looked at the calculator too quickly. It's 0.0113. I knew that didn't sound right. 0.0114 1.4 centimeters. So when this thing moves a half a meter, this thing goes 1.4 centimeters. 50 centimeters to 1.4 centimeters. So yes, you get this great multiplication of your force, but you're going to have to move this force. You're going to have to apply this force in a great distance. The way this really works in the gas stations is, let's say you have your lift for the car over here, and all these pipes, usually there's like some crazy sinuous set of pipes over here to the controller. So you have this enormous length. To get a car to go 6 feet, you need, to get a car 6 feet up in the air, 7 feet up in the air, you need hundreds of feet of piping to get that to work. Hope that makes sense. So just to clarify, distance, output piston would be 0.014 meters.